So, good morning, my dear students. So, today in these sessions, we are going to learn fourth problem on the compression helical spring. Okay. So, design a compression helical spring carrying a load of 500 Newton. So, in this case, here the compressive force, how much compressive force is acting here? The 500 compressive load is acting on the helical spring, here. Is it right? So with a deflection of 25 mm. So if the compressive force is acting on the spring due to deflection is occurring, where it is occurring here? It is occurring in the helical spring. So the deflection, it is represented by Y. How much is given here? 25 mm. As well as this spring index may be taken as 8. So here spring index, how much is given? C equal to 8. So in this case, we need to assume the following value for the spring material. The first thing is the permissible shear stress. This permissible shear stress tau, the shear stress is represented by tau equal to how much is given here? 350 Newton per mm square is given here. So this modulus of rigidity, it is represented by G. How much is given? 84 into 10 power of 3 Newton per mm square is given in this equation, in this problem. So the first of all, we need to find out the value of K. If you want to find out the value of K, then you need to follow the Wahl's factor method. If you follow the Wahl's factor method, then you can easily solve the value of K. So let us see over here. This Wahl's factor, from this one we can easily get the value of K. The Wahl factor equation is K equal to 4 into C. C is indicate that it is a spring index. 4 into spring index minus of 1 divided by 4 into spring index minus of 4 plus 0.615 divided by C. Is it right? So we have to, so for this Wahl's factor equation, you have to refer the page number 169 and 11.2a from the design data handbook by Mahadevan. Design data handbook by Mahadevan. Then you can easily get this equation. Okay, so page number 169. So in this case, K is unknown value. We need to find out the value of K equal to 4 as it is. Here C value, the spring index, the value is given as how much? 8 here. Is it right? 4 into 8 minus of 1 divided by 4 as it is. C value is spring index value is given as 8 minus of 4 plus 0.615 divided by spring index value is 8. So if you divide this whole value, then you will get the value is 1.107 plus if you divide the 0.615 divided by 8, then you will get the value of 0.0768. if we add the value is 1. Okay, so if you add the value is 1.107 plus 0.0768, then you will get the value of Wahl's factor K equal to 1.108. Is it right? After the getting of the K value, we need to find out the value of D. Is it right? Then you have to refer the shear stress in the helical spring. So because in this equation we are assuming the shear stress value. If you are assuming the shear stress value, then you have to refer the formula of shear stress in the helical spring. So you have to refer the equation tau is indicate that it is a shear stress equal to 8 is a constant value. F is indicate that it is a compressive force. Which force? Compressive force is acting on the helical spring. Into D is indicate that it is the outer diameter of the helical spring, and K is indicate that it is a Waltz factor. K value is given divided by pi into diameter. Is it right? Spring diameter. Then 8F as it is, K is as it is, divided by pi d cube. So we know very well the spring index C equal to outer diameter by inner diameter, we know very well. Is it right? Then if you are divide here, okay, so here cube is there. If you are remove one more cube here, like d square into d, if the bases are same, the power should be add. D square plus 1 should be how much? D cube. So what I'm doing here, I am removing one d here from this side. So d is as it is, divided by 1 diameter I am removing here by d. Is it right, Nadia? Then after that, so we know very well outer diameter by inner diameter is equal to spring index value. So C 8 as it is, F value is the compressive force is acting on the helical spring is given as 500 Newton into K, the Waltz factor value is given as 1.18 into this d by d is nothing but C value. Is it right? The C value how much is given to here? Spring index value. The spring index value is given as how much? 8. Is it right? How much? 8 divided by pi is constant value 3.142 by d square as it is. So after that we need to cross multiply here. 350 into pi, 350 into pi into d square equal to 8 into 500 into 1.18 into 8. D square from this side. Again you have to divide here 8 into 500 into 1.18 into 8 divided by pi into this value. Cross multiply into 350. After that, if you remove this, square, if you remove this square, then it is making as power is 1 by 2. 1 by 2 value is under root of 1 by 2 value is root. Is it right? So whatever the value is getting, whatever the answer is getting, after that you will take the value in the root. Then after that you will get the value is diameter D is equal to 5.86 mm. So these diameters indicate this is the wire diameter of the helical coil spring. Is it right? After the getting of the D, then we can easily find out with the help of coil diameter. This how the coil diameter we can easily get here. We know the formula. What is the formula is there? C equal to outer diameter by inner diameter. Just know already we have studied above. I will show you here from this one. C is equal to D by small d. Is it right? Just you have to multiply C into D here, C into D like this, C into D equal to D. So then you can easily get the value of coil diameter. Coil diameter nothing but we have to find out the value of D. So D equal to C into D. C is the spring index value. How much we got it here? Already is given in the problem. How much? 8 into this small d, the wire diameter how much is given here? 5.86. If you multiply the value 8 into 5.86, then you will get the value is 46.88 mm. Is it right? The diameter always we are measuring in mm. This is the diameter. D is indicate that it's the coil diameter of the helical spring. Okay, after the getting of the diameter, coil diameter of the helical spring, after that we need to find out the active number of coils we need to find out. So if you want to find out the active number of coil, I equal to Y is indicate that it is a deflection due to the apply of compressive force on the spring. Is it right? G is indicate that it is a modulus of rigidity of the material, and the small d is the indicate that it is a coil diameter. Is it right? And divided by 8 into F. F is indicate that it is a compressive force is acting on the helical spring. C is indicate that is a spring index. So you have to refer this formula, page number, equation is 11.6, page number is 170. You have to refer from the design data handbook by Mahadevan. Is it right? So I is as it is, because in this case what we need to find out, we need to find out the actual number of coil we need to find out in this case. So if you want to find out the actual number of coil, I is equal to 25 into the Y deflection value. How much is given here? 25 is given. So the modulus of rigidity, how much is given here? 84 into 10 power of 3 is given here. So small d, okay, so the modulus of rigidity is how much is given here? 84 into 10 power of 3 is given here. So d small d, how much is given? Diameter of the coil. Diameter of the coil is given as 5.86 is given here into 8 as it is. So this F value, how much is given here? This compressive force is 500 Newton is acting on the helical spring, we know very well. The C's indicate spring index value is given as 8 power of cube. So if you divide the whole the value, then you will get the value is 6 mm with the help of calci. Is it right? After that, after the getting of the value of active number of coil, then you need to find out the value of pitch of the spring. You need to find out with the help of minimum free length of the spring by assuming the ends are bent before the grinding. Is it right? So first of all, that is the equation LO, okay, is greater than or equal to I plus 2. Is it right? I nothing but active number of coils plus 2 into diameter of the coil plus Y is indicate that it is a deflection plus 8 is represent the it is a clearance. Is it right? So you have to refer this page number 174, equation number is 11.18 from the design data handbook by Mahadevan. So if you want to find, first of all, what you need to find out, you need to find out the value of K. If you want to find out the value of A, this A is indicate that it is a clearance value, A equal to X into DI, inner diameter of the coils. So you have to refer the page number 174, equation number is 11.18C from the design data handbook by Mahadevan. Okay, so from the figure number 11.6, page number 174, please refer. Okay, for C is the spring index value is given. C is equal to how much is given here? 8 is given. So if the diameter, if it is greater or equal to less, then you have to follow the 0.8 mm. We know very well. So X value is equal, approximately is equal to the 0.19 mm. We know very well. Then A is as it is. If you refer the figure number 11.16, then you will get this value. Okay, A equal to as it is, X value is how much we got it here? 0.19 into DI. DI how much we got it here? We got the value is 5.86 already. We know very well, already we solve. Okay, now here into 6 is given. If you multiply this whole the value, then you will get the value is 6.68. okay, so after that, if you're getting the value of this one, you need to substitute here. So let us see above. Okay, this is D, how much? 5.86. I value, this is different here, X into D into I is already we have solved here. How much we got here? I is 6. Is it right? Don't be confused. I how much we got here? 6 plus 2. D how much we got here? We know very well, 5.86 value plus Y is the deflection, how much we got? 25 plus A is the clearance value, how much we got here? 6.68. So if you add this whole the value, then you will get the value is 78.56 mm you will get, because the diameter and length we are measuring in mm only. So after that, after getting of this one, actually we need to find out the actual number of coil, as well as we need to find out the solid length of this helical coil of the spring we need to find out in this case. So from the table number 11.4, page number 189 from the Design and Handbook by Mahadevan. Assume the square and ground and type D. Okay, so actual number of coil, the what is the formula? I equal to I plus 2. Is it right? I dash equal to I plus 2. So I value is given how much dear? 6 plus 2. If you add, then you will be get the value of active number of coil is how much it will be there? Total 8. And the solid length I plus 2 into D, that is the here solid length equal to here equal to I plus 2 into D. So I, how much we got here? Already we know very well this active number of coil. There is no need to take this value of I equal to 6. So in this case, what we need to find out? In the solid length, we have to take this value of active number of coil. You have to remember this point. Is it right? So here active number of coil is how much is given here? How much we got it? 8 value. Okay. After that, here how means this is 6 plus. Oh. Let's see, because I is 6 plus 2 that I'm doing here. 6 plus 2 should be how much dear? 8 only. 8 into 5.86. If you multiply this term, then how much will you get dear? If you are multiplying this value of 8 into 5.86, then you will get the value is 46.88 mm. After that, we need to find out the free length. We need to find out in this case. If you want to find out the free length, LO is equal to IP plus 2 into D. So LO already we find out the from this equation in the above. How much we got here? 78.56. We got the free length. We got it equal to I value is how much is there? 6 only. Is it right? Into P as it is plus 2 into D value. How much we got here? 5.86. So if you divide this whole the value 78.56 minus 2 into 5.86 divided by 6, then you will get the value of pitch is how much? 11.14 mm. Then you will get from this problem. I hope so you got the concept regarding this problem. Please do the practice again and again, then you will get the concept overall, because the practice is the most important. If you guys is not doing the practice, you are not able to solve the problem. Okay, so if you have the small doubt regarding these sessions, please write down in the comment box, and please don't forget to subscribe my channel. Thank you dear.